Okay, so aside from the classification by type and by order, we have also the what we call the classification of DE, classification by linearity. So we have the linear DE and nonlinear DE. So when we say linear DE, so the differential equation is linear if the dependent variable appears in a linear form or linear fashion. Linear DE, I mean DE is linear if the dependent variable appears in a linear fashion. Okay. So we have here another terminology which is the dependent variable. Okay. So let's before we can classify the differential equation if it is a linear or non-linear, then we must first define some terminologies here. So we have this dependent variable here. So what is this all about? So let's define first. So when an equation involves one derivative with respect to a particular variable, say we have dy over dx, so plus y is equal to 1. Okay, so when an equation, say this is our equation, involves one or more derivatives, so in this case we have only one derivative with respect to a particular variable. So we have a derivative of y with respect to variable x, and this variable is called independent. Okay, and a variable is called dependent if a derivative of the variable occurs. So the derivative of the variable y occurs. So we have the derivative of y. That's why this variable y here is the what we call dependent variable. Okay, once again, let me rewrite here. When an equation involves one or more derivatives, with respect to a particular variable that variable is called independent variable. Okay. Wherein a variable is called dependent if a derivative of that variable occurs. Okay, once again, when an equation involves one or say we have more derivatives, so this equation here involves one derivative. Equation involves one derivative with respect to a particular variable. So this derivative here is with respect to a particular variable. That variable is called independent variable. Okay? Once again, when an equation involves one or more derivatives with respect to a particular variables, say we have here a with respect to x, so this variable is called independent variable. Wherein a variable is called dependent if a derivative of that variable occurs. So the derivative of y, so we have here the derivative of variable y. So a variable is called dependent if a derivative of that variable occurs. So here we have the derivative of variable y occurs. So this variable is called now our dependent variable. Okay, so let me rewrite our equation. Okay, let's go back to the definition of our linear equation. So the said differential equation is linear if the dependent variable, so in this case our dependent variable by definition is y. Our dependent variable here is y. This is our dependent variable. Appears in a linear fashion. So the all of our dependent variables here, either this variable y and its derivative, it must be in linear form in order for us to consider the whole equation linear. So the variable y here is linear, and the derivative of the variable y here is also linear. Linear, or they are in linear form. So the variable y here and the derivative of this variable y is also in linear form. That's why our equation sample equation here is called linear. Okay, so another example. See, we have we have dy over dx plus y squared is equal to 1. Okay, so once again, we have here a differential equation, and our dependent variable here is, once again, a variable is called dependent if a derivative of the variable occur. So the derivative of the variable y occur, so we have derivative of y, so this variable y here is called dependent. And for this equation to be linear, to consider linear, then the dependent variable and its derivative must appear in linear fashion. So let's examine one by one our equation. So we have dy over dx. This is linear. In the second form, we have dy squared, wherein this dependent variable y here is raised to 2, and that is not linear. Therefore, this equation is considered a non-linear DE.